Hi students, good evening. Welcome to this video session. I remain Samuel Dominic Chukwu Emeka, aka Sam Dom for Peace. In this video session, we shall discuss literal equations. This is part 3. Specifically, in this video, we shall solve problems regarding literal equations. We shall solve problems on literal equations, and those problems we shall solve are the past question papers, past questions from the ACT, from the WASSCE, from a JAMB, from CSEC. So ACT, WASSCE, JAMB, and CSEC. We are going to solve questions on literal equations from these exams. This is part 3, so that means that there is part 1 and part 2. So please, when you go to my website, www.samuelchukwuemeka.com or www.chukwuemekasamuel.com, or you can go directly to this website, www.expressions-equations.appspot.com. So when you go there, if you go directly to this website, just go to videos and you will see literal equations, and you can see the playlist on literal equations. So you view part 1 and part 2 prior to viewing part 3. Important, very important. If you go to my website, samuelchukwuemeka.com or chukwuemekasamuel.com, then you click on mathematics, click on algebra, and you will see literal equations. In the video section or in the notes section, just click on any one of them and you will get access to these videos. Okay, so I am going to be reading from, I have solved these questions and I think I've explained it well. So why am I doing these videos? These videos are for those who are visual learners, those who would like a verbal explanation. Otherwise, I think I have explained it very well on this website. If you go to solve the examples, if you go to this website and go to solve the examples, you click on literal equations, you will see the questions we are going to solve tonight. I think I explained it well. Okay, I explained it step by step so that you would even understand it. Even without this video, you would understand it. However, some folks prefer verbal explanations. So I'm going to explain it step by step also in this video. Okay. But the questions, I'm getting it from here, so it would be better, you just pay attention. My advice to you would be, as you're viewing the video, or as you view the video, read the notes, read the solved examples, so that way you can, as you're viewing it, you're also looking at the solved examples. It will be good when I'm solving a question, you pause it, try to solve it on your own first. solve it on your own first. Then you now check, compare your solution with mine. Alright, so we begin here. Question 19. Question 19 is ACT. So you might ask me, okay, Mr. C, what of questions 1 through 18? This video specifically are for solving past questions. In the part 1 and part 2, I solved many questions there that are not past questions. This one specifically is for only past questions. And those past questions are from question 19 till, I don't want to say the end of the questions now, but just know we are going to solve as many questions as possible. Es possible, we shall solve as many questions as possible so that you will get a good understanding of this topic. To be honest, this is one of the topics that you should be happy, like you should even ask to see in your exams, because you can, get it right away. So question 19 is from ACT. Each student's project in a history seminar is given a point score by the teacher and by each of the other students in the seminar. A student's project grade, G, lowercase g, that's a variable. A student's project grade, G, is determined by the formula. G is equal to 3t plus s all over 3 plus n, where t is the score the teacher gives, s is the sum of the scores the students give, and n is the number of students in the seminar. What is t in terms of g, s, and n? So they want us to solve this for t. Alright, before we do this, I have said this several times. I tell my students this. You look at this question now, is a word problem. Technically not. Technically not, because this question, they would have just said, solve for t in the formula. Or they might say solve g equal to 3t plus s divided by 3 plus n, 4t, just like that. They could just say it just like that. Alright? They could just say just like that. Yeah, when I go here, it's for my laptop, not to stay on. I don't want to set it for the power to be continuous, so don't worry. It's good movement, I want to be just move like this. It's just to turn my laptop to stay on. So they could have just said this without having to write all those word problems. However, like I have always said, word problems demonstrate the real world application. So we will not run away from word problems. Okay? And the way solving a problem is not to always keep saying it. I don't like word problems. I don't like word problems. Okay, we have heard that so many times. You don't like word problems. What should you do about it? Okay, it's not I don't like word problems. So it demonstrates the real world application. And some students, they see this now on the test, they don't even attempt it. Now, if they just ask this question like this, solve for T, just like that, without word problems, without the English there. Word problems is just translating English to mathematics. But without the English there, some of those students would be able to solve this. However, they see the English, they don't even want to read it. They do not want to read it. You have to read it first to understand it. And they do this most often on the they do this sometimes frequently on the ACT. You see a lot of word problems that, hey, can't you just paraphrase this? This is like 3 or 4 sentences. You can paraphrase it in only 2 sentences. That makes meaning right away. Just go straight to the point. All right, but I tell my students this. If everybody passes the ACT, what would you say? Hey, it's an easy exam. Very easy exam. You will not take it as anything. Folks, they don't set exams for everybody to pass. Nobody sets exam for everybody to pass. Exam is meant to be as a sieve. Okay? Now, but you know Mr. C wants you to pass anyway. You know my quote, the joy of a teacher is the success of his students. Yeah. I want all my students to pass. Yeah. But exams, tests, external tests, or external exams like this is meant as a sieve to check proficiency in understanding real-world applications. So they ask it, but you will say, no, I have to overcome this obstacle. I don't want this, I have to overcome this obstacle. So take time and read it to understand it, then paraphrase it. You know, if you go to my notes on this website, you see, read the notes on what I said about word problems. Read it. Okay? So you can do it. Don't be thrown off by this kind of questions. No. You see, this whole questions, I don't know, this whole question, the simple thing is solve this for T. Simple. That's it. That's it. Alright, but they want you to know, to test that skill in understanding real world application of literal equations. To know what does variables mean? How do we use variables in the real world? As you can see in the question, they describe the variables there. The G, the T, the S, the N, what they mean. So that's to check for your understanding of the variables and how literal equations are used in the real world and how you can solve a variable in terms of other variables, or making a variable the subject of the formula, or subject of the equation, or subject of the relation. All right. I have this. I remember this story. Let me tell this story and we'll continue. Okay. So I had this teacher in my school. I think that was in junior secondary school. Yeah, either I think junior secondary school or senior secondary school. I can't remember. In Nigeria, yeah. Junior secondary school is middle school in America. Senior secondary school is high school. So I had this teacher, either in middle school or high school. So she would say, I wish you what you wish yourselves. Like, she wouldn't say, I wish you success. No. I mean, most teachers will say, hey, I wish you success. Okay? Of course, you know, my students, I wish you success. Yeah. But this particular teacher will say, I wish you what you wish yourselves. So, one day I was thinking about what she said. And I now correlated it. I now correlated it with you know, with the fact that some people don't wish themselves well, you know, and I don't know why. I have no idea. I have no idea. Like, to be honest, some people don't wish themselves well. I mean, why would you kill yourself? Somebody who killed himself or herself, of course, that person doesn't wish himself or herself well. Why are you gonna kill? Why would you think? Why would you even think about that? Why? So, some people don't wish themselves well. But how she said, I wish you what you wish yourselves, you know. And that reminds me, you know, in Mark 12:30, you know, the two greatest commandments. Jesus Christ said, the two greatest commandments. Mark 12:30, the first one, the first greatest, is love the Lord thy God with all your heart. First is heart. With all your soul, with all your mind, and with all your strength. Love the Lord thy God with all your heart, with all your soul, with all your mind, and with all your strength. And then the second one is love thy neighbor as thyself. Love thy neighbor as thyself. Okay, all right. Now, there are those who don't like themselves. That is the problem. The second one. First one, no problem. The second one, there are those, second one is in verse 31. Okay, first one is in verse 30. Love God. Second one, verse 31. Love thy neighbor as thyself. Okay, but the issue is this: some people don't like themselves. So that's the thing. So when I say, "Oh, I wish you what to wish yourselves," well, some people don't wish themselves well, and I have no idea why. Why? Okay? Why? You know. So you now go after that Mark 12:31. Then you now go to John 13:34. John 13:34. Jesus Christ now said, "A new commandment." This is now a new commandment I give unto you: love one another. As I have loved you, you must also. It said must. As I have loved you. So this is not love your neighbor as yourself. It's now love one another as God loved us. See that now? Because some people don't even like themselves. So okay, hey, those people who don't like themselves, now this is the new commandment for everybody. Love one another as I have loved you. Okay, so we need to like ourselves. We need to. And then we need to love our neighbor as ourselves. And then we need to now love our neighbor as God loves us. All right. So let's solve this for T, which means we need to isolate T. We need to isolate T. Isolating T means we have to make it to be by itself. And we have to put it on the left-hand side. Left-hand side. When you isolate it, you put it on the left-hand side by itself. Now, some people might ask me, why do we need to put variable to the left-hand side? Okay, I've said this before in my previous videos. When you go to the store and you want to buy, let's say, a pencil, and you do not see the price tag on the pencil. So you go to the cashier, you ask, hey, please, what is the price of this pencil? So let the price be P. Let the price be P. So which one is better? Which one is better to the ear? The price of the pencil is $3. You know, let the price be P. So which one is better to hear? The price of the pencil is $3. Or $3 is the price of the pencil. You see that? So the first one is better to hear. We always want the variable to be on the, this is not incorrect. Yeah, but we always want the variable, even when we solve equations, we want the variable, the unknown, to be on the left-hand side. All right? So here in literal equations, which means solving for a specified variable in a formula or in an equation or in a relation, we want the variable to be on the left-hand side. So I normally say, I will say swap. Now, please, what I say now, I have already typed it. So I will not be writing this again because I have already typed it. Yeah, what I'm saying, the transcript of this video is already written for you in this website. So I will not be writing my steps, I will just be saying it verbally. But because I have already typed it on this website, so there is no need, and we have a lot of questions to solve. So I will not be writing it here, no, because I have already written it on my website. So I'll say swap. Swap means let the left-hand side be the right-hand side, and let the right-hand side be the left-hand side. So 3t plus s over 3 plus n is equal to g. And here you can cross multiply. I mean, whenever you have one term on the left-hand side, one term on the right-hand side, you can cross multiply. Okay, I'll do that as the second method. But some people will prefer to, because remember we want to isolate t. So some people will say multiply both sides by 3 plus n. Multiply both sides by 3 plus n. So this will be 3 plus n times g. So as you can see now, I will use the yellow chalk to cross out. Bam, bam. So we now have that 3t plus s is g times 3 plus n. Then you now say subtract s from both sides. Subtract s from both sides. So 3t plus s minus s is g 3 plus n minus s. So this is gone here. S minus s is gone. Then you now have 3t to be g times 3 plus n minus s. Then you now say divide both sides by 3. Divide both sides by 3. So 3t divided by 3 is g 3 plus n minus s divided by 3. Bam, bam. So your t will be g 3 plus n minus s divided by 3. That's it. That's your answer. Okay? Now, if you don't like what I just did here, you can also do cross multiply. You can. From here, 3t plus s over 3 plus n, you can say this is g over 1. Whenever you have an equation and you have only one term on the left and one term on the right, you can do cross multiply. You can. That is the second way. The first way is multiply both sides by 3 plus n. Yeah, so you can cross out. Remember, we want to isolate t. Yeah, but some people might say, hey, let's do cross multiply. And cross multiply means you multiply the numerator of, you have a fraction, just one term, one fraction on the left and one fraction on the right. If you have something like this, you cannot do cross multiply. No, you cannot. It has to be only one fraction on the left and one fraction on the right. Only. It's only one fraction on the left, one fraction on the right, only. And cross multiply or cross product, some textbooks will say cross product. Some will say cross multiply. Some will say the butterfly method. It means, let me touch my laptop to wake it up. It means multiply the numerator of the fraction on the left with the denominator of the fraction on the right. And also multiply the denominator of the fraction on the left with the numerator of the fraction on the right. So cross multiply or cross product or butterfly method. So this means that 3t1 times 3t plus s is g times 3 plus n. Of course, 1 times this is 3t plus s equal to g times 3 plus n. Then you can finish it from here. You subtract s from both sides and then you divide both sides by 3. So that is the second way you can do it. Alright? Oh, I missed that shot. Okay, let's do question 20. We have a lot of questions to do, so we have a lot of questions to do. A lot. Question 20. I hope you stay with me, right? Question 20 is ACT. Yeah, so you now check the option. The option there, if we finished it, okay, if we finish it, because I just looked at the option, I have the options for those multiple choice questions. ACT is a multiple choice test. And I don't see that option, so let's finish it. We had that 3t is g, 3 plus n minus s. T is g, 3 plus n minus s over 3. In the option, they want you to distribute. So t will be 3g plus gn minus s over 3. Yes. That is K. Yeah, that's the option there. Alright, question 20 is also ACT. A formula for the area of a rhombus. A formula for the area of a rhombus is A equal to 1/2 d1 d2. d1 times d2. Where d1, d subscript 1, and d subscript 2 are the lengths of the diagonals. Which of the following is an expression for d2? So for d2. So let's swap. We have that 1/2 d1 times d2 is equal to A. Multiply both sides by 2. Because we don't want the fraction. Remember, we want to isolate d2. This is for d2. For d2. So multiply both sides by 2. So 2 times 1/2 d1 d2 is equal to 2 times A. So 2 crosses out, bam, bam, that's gone. d1 d2 is 2A. Then divide both sides by d1. Divide both sides by d1. So d1 d2 divided by d1 is 2A divided by d1. Bam, bam. So your d2 is 2A over d1. And that's it. Alright? 2A over d1. Option F. Next one is question 21. Question 21. Question 21 is WASSCE. WASSCE. If R R is equal to h over 2 plus d squared over 8h. D squared over 8h. Express D in terms of R and H. So solve this for D. Solve it for D. Alright? So, can we swap? Let's swap. So this will be h over 2 plus d squared over 8h equal to R. Subtract h over 2 from both sides. Subtract h over 2 from both sides. So h over 2 plus d squared over 8h minus h over 2 equal to R minus h over 2. Do you see how I'm showing? I am taking time to show all this work, so you will understand each step that I do. Okay, h over 2 minus h over 2. Bam, bam. That's gone. So we have d squared over 8h equal to R minus h over 2. Multiply both sides by 8h. Multiply both sides by 8h. You cannot do cross product here. You cannot. You cannot, because this is on the right hand side. You don't have only one fraction. Like you don't have, it should have to be a term. Cross product is when you have only a single term that is a fraction on the left, a single term that is a fraction on the right. Otherwise you don't. Okay? You must have at least one fraction for you to do cross product. If the other one is not a fraction, you can put it as a fraction. If it's like k over 1 is the fraction. Yeah. But here you don't have a single term, you have two terms here. So no. Cross product is only a single term on the left and a single term on the right. That is the only way you do, and it has to be an equation. If it's not an equation, do not do cross product. I have seen some students, they multiply fractions and they do it as cross product. No! When you multiply fractions, you watch my video on multiplying fractions. When you multiply fractions, you multiply along. You don't multiply across. You multiply fraction, you multiply along. Numerator times numerator. Denominator times denominator. Now, you can cross out. If something can divide, you know, you can simplify then multiply. Or you can multiply then simplify. But essentially, you multiply along. Cross, and it doesn't have to be, and it will be an expression that is multiplying fraction. It's an expression, no equation, no equal to. Cross product, it must be an equation, must. And it must be a fraction, single term fraction on the left, single term fraction on the right. And you multiply numerator of the fraction on the left with the denominator of the fraction on the right, equal to denominator of the fraction on the left times the numerator of the fraction on the right. Okay. The products, equate the products. Yeah, that is cross product. Okay, here we now multiply both sides by 8h. Multiply both sides by 8h. So we come here, 8h times d squared over 8h equal to 8h times r minus h over 2. You see that? So you now have d squared is 8h times r minus h over 2. And then you just take the square root of both sides. Take the square root of both sides. What do I mean by taking the square root of both sides? Multiply the exponent of each by 1 over 2. That is what I mean. you have to view my videos on radicals. 2 times 1 over 2 is 8h r minus h over 2. All these raised to power 1 over 2. Because this means like 1. This is like 1. So 1 times 1 over 2. 1 times 1 over 2. So 2 times 1 over 2. Yeah. But you know, this is just explaining it another way. Because when you square root of the square of a number is the number. Square of the square root of a number is the number. Cube root of the cube of a number is the number. Or if you don't want me to put number, I can put term, okay? Cube root of the cube of a term is the term. Cube of the cube root of the term is the term. Square root of the square of the term is the term. Square of the square root of the term is the term. Yeah. But this is just to show you that is the way it is. So this is D is 8h r minus h over 2 raised to power half. So this means that D is square root of 8h times r minus h over 2. Because this exponent, if you view my videos on exponents, fractional exponents gives you radicals. Fractional exponents gives you radicals. Alright? So, the answer is not there in the option. So let us simplify this. Let's simplify it so we can get the answer that is there. So we now have let's simplify 8h times r minus h over 2. D is square root of this. So let's do it step by step. R minus h over 2 is the same thing as saying 2r, because if you look at this here, if you want me to show all my work, r minus h over 2. So this means r over 1. That is what it means. What is the LCD of 1 and 2? 2, 2. What will you do to 1 to give you 2? This times 2. Now, it is my expectation that you've already learned fractions. Alright, so in the subsequent questions, to save time, it's my assumption you already know fractions. Before you do equations, you must know fractions. So 1 times 2 is 2. So r, this is times 2 times 2. So this is 2r. And this is times 1 times 1. So this is h over 2. So this will give us 2r over 2 minus h over 2, which is 2r minus h all over 2. Okay, so 8h times r minus h over 2 is 8h times 2r minus h all over 2. That is what it means. Alright, so 2 into 2 is 1, 2 into 8 is 4. So this will give us 4h times 2r minus h. That is what it gives us. Now, this implies that our D is square root of 4h times 2r minus h. times 2r minus h. Yeah, square root of 4h times 2r minus h. That is option A. That is the answer. Alright? Next question. I hope you understand the concept. The concept. Next question is question 22. Question 22 is JAMB. If two graphs y equal to px squared plus q and y equal to 2x squared minus 1. 2x squared minus 1. So these two graphs intersect at x equal to 2. Intersect at x equal to 2. Find the value of P in terms of Q. So of course, find the value of P in terms of Q means make P the subject of the formula. That is what it means. So solve this for P. Solve this for P. Yeah. But these two intersect first. So they intersect at x equal to 2. So y is equal to y. Everything is not straightforward. Mathematics, they twist questions. So this is still subject of the formula, literal equations. But first of all, let's note the fact. Let us note the fact that they intersect at x equal to 2. So this means y is equal to y. So this implies that px squared plus q is equal to 2x squared minus 1. Right? Now when x is equal to 2 means p times 2 squared plus q is equal to 2 times 2 squared minus 1. Right? 2 squared is 4. So this is 4p plus q equal to 2 times 2 squared is 4. 2 times 4, 8. 8 minus 1. So this is 4p plus q is 7. And you want to isolate p. So subtract q from both sides. Subtract q from both sides. So 4p plus q minus q equal to 7 minus q. Please, when you're adding or subtracting, it should come, multiplication doesn't matter. 2 times 3 is equal to 3 times 2. Addition doesn't matter. 2 plus 3 is equal to 3 plus 2. But when you're subtracting from, alright, you have to make sure. If you say subtract 2 from 5, that means 5 minus 2. If you say subtract 5 from 2, it means 2 minus 5. Okay, please. That reminds me, read the notes on translate word problems. I talked about it, yeah. Okay. Add to. Subtract from. Subtract from. Multiply by. Multiply by. Divide by. Add to. Subtract from. Multiply by. Divide by. So subtract from. Don't come and say q minus 4p plus q. Don't do that. Subtract from. Subtract 2 from 5 means 5 minus 2. Subtract 5 from 2 means 2 minus 5. Okay, please look at those videos. So q minus q is gone. You now have 4p is 7 minus q. Divide both sides by 4. 4p divided by 4 is 7 minus q over 4. Bam. So p is 7 minus q over 4. That's it. That is it. All right. Question 23. Yeah, so the answer here is option B. Option B. Question 23 is CSEC. CSEC. Caribbean examination. CSEC. Using the formula T equal to square root of 5m over 12n. Calculate the value of T when n is equal to 20 and when n is equal to 48. Then express m as subject of the formula. Then express m as subject of the formula. Okay, folks, I did not bring, to be honest, I didn't bring my calculator. I did not, but I will simplify it as a fraction. I will simplify it as a fraction. And if you look at my notes, you will see how I solved it. All right. I didn't bring my calculator. I'm sorry. But I already solved this. Okay. I will show it here, simplify it as a fraction, and then the main thing is the second part, express m as the subject of the formula. So, but they asked us to find t. So I will just simplify it, and then you read my notes to see the holes, to see how I use calculator to do it. So this is 5 times 20 over 12 times 48. Right? So we can simplify. 4 into 12 is 3. 4 into 20 is 5. And we cannot simplify anymore. So this means that t will be square root of 5 times 5 is 25 over 3 times 48. 3 times 8, 24. 4 carry 2. 3 times 4, 12. Plus 2, 14. 25 over 144. Right? 25 over 144. So this will be 5 over 12. T is 5 over 12. Square root of 25 is 5. Square root of 144 is 12. Alright, this is the first part, I. Because it has two parts, I. Then I is express m as a subject of the formula. Okay, that's the main thing we want. So you have t is square root of 5m over 12n. Square both sides. Square both sides. Okay, because what this means is that t is equal to 5m over 12n raised to exponent half. That is what it means. That is the meaning. That is what it means. So, and like I said, the square of the square root of a term is the term. The square root of the square of a term is the term. So when you have a square root and you want to free it up, square it. The cube, similarly, the cube root of the cube of a term is the term. And the cube of the cube root of a term is the term. Alright? Now for the square roots, I know some people will say, okay, you have to be specific on the real number. For the cube root, the fifth root, the seventh root, the eighth root, the seventh root, the ninth root, But I don't want to go into those now. I just want us to focus. Square root of the square of the term is the term. Cube root of the cube of the term is the term. Okay, at least for this level. Alright? So this is actually what it means. Square root is fractional exponents. fractional exponents. So we now say square both sides. Square both sides. Square both sides. So this will now give us, t squared is 5n over 12n, 1/2 times 2. So t squared will give us 5n over 12n. Because this crosses out, that crosses out. So we now have t squared is 5n over 12n. Swap, when you swap, you now have 5n over 12n equal to t squared. Multiply both sides by 12n. Remember, we want to isolate n. Okay, that is make n the subject of the formula. So multiply both sides by 12n. So 12n times 5n over 12n equal to 12n times t squared. And if you want, you can say 5n. If you want, you can write 5n, because some people will say, hey, for subtract, you put it afterwards. Why don't you do the same thing? That's fine. We can do the same thing. 5n over 12n times 12n equal to t squared times 12n. Multiplication is commutative. Multiplication of real numbers is commutative. Also, addition of real numbers is commutative. If you say 2 times 5 or 5 times 2, that's the same thing. But 2 minus 5 and 5 minus 2 is not the same thing. If you say 2 plus 5 and 5 plus 2, is the same thing. You say 2 times 5 and 5 times 2, is the same thing. But when you say that is multiplication and addition of real numbers are commutative, doesn't matter if you place this first. Yeah, but when you come to the addition, subtraction and division, they are not commutative. 2 divided by 5 and 5 divided by 2 will not give you the same thing. 2 divided by 5 is 0.4. 5 divided by 2 is 2.5. So they are not the same thing. So just take note of that. It doesn't matter, when I place one in front of, first. Doesn't matter. So, this cancels out. So we have that 5n is 12nt squared. 12nt squared. Then you divide both sides by 5. Divide both sides by 5. So you now have 5n divided by 5 is 12nt squared divided by 5. Bam, bam. So your m is 12nt squared divided by 5. That's it. That's it. Okay. Question 24 is also CSEC. It's also CSEC. The formula for the volume of a cylinder is given as V is equal to pi r squared h. Make r the subject of the formula. So this is, here is for m. And this one is for r. Make r the subject of the formula. So we can swap. Swap means let your left hand side be your right hand side. Let your right hand side be your left hand side. So pi r squared h is equal to V. Divide both sides by pi h. Divide both sides by pi h. So pi r squared h divided by pi h is v over pi h. Right? Okay, so let's finish it here. So we cross out bam, 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 bam. So we have r squared is v over pi h. Then take the square root. Take the square root of both sides. Alright? So square root of r squared is square root of v over pi h. So square root of the square of a term. The square root of the square of a term is the term. So r will be square root of v over pi h. And this becomes your answer. Okay? That becomes your answer. Next question. Yeah, CSEC questions are not multiple choice, so you just have to simplify them. Yeah, they are not multiple choice. So next one is question 25. We're getting there, folks. Question 25 is JAMB. JAMB. Make R the subject of the formula. So you have x over r plus a equal to a over r. So this means solve for r. This is a fraction on the left, a fraction on the right. A term, a single term fraction on the left, a single term fraction on the right. So just use cross multiply, cross product. Alright? Cross product. Cross product is easier to use. So we have that a times r plus a is equal to x times r, which is xr. Distribute. Just go ahead and distribute. So we have, when I say distribute, I mean apply the distributive property. Okay. You can view my videos there. If you go to this website, it has all these. It has anything expressions, anything equations. Okay. So this is a times r is ar plus a squared equal to xr. You now want to get like terms. Get the like terms. Now, I don't like, and I think if you look at the options, they don't like negative. I don't like negatives. You know, I don't want to, because if I move this a squared here, if I say subtract a squared from both sides, I'll be dealing with a negative a squared here. Come on, this is JAMB. You're working with time. You look at the options, there's no negative a squared. And you don't want to divide letter by a negative number. You don't, I mean, to save time. So I'm gonna just subtract AR from both sides. That's subtract AR from both sides. Okay? AR plus a squared minus AR equal to XR minus AR. I want to get the like terms in R. So AR minus AR, that's gone. So we have a squared is equal to XR minus AR. Swap. XR minus AR is a squared. Factor by GCF. Factor the left hand side by GCF. GCF is R. Now I'm showing my work, but I hope you know that if you do like this on JAMB, you will not solve the question under 1 minute. I hope you know. I hope you know that for JAMB, just bam. You move this here. A squared is XR minus AR. So I am just explaining this like for the beginners. So you can grasp the concept. Once you grasp the concept, JAMB question, you should do it like I think that's under 2 minutes, or about 2 minutes. You should do it well, on time. Okay, read the instruction I posted there. Okay, so we factor this left hand side by GCF. The GCF is R. So R of x minus a is equal to a squared. Then you divide both sides by x minus a. Divide both sides by x minus a. So I have R of x minus a divided by x minus a is equal to a squared divided by x minus a. So R is a squared divided by x minus a. That's it. That is it. Okay? 26. Question 26. Question 26. This question 25, the answer is option D. Option D is the answer. It's a JAMB question. Question 26 is ACT. Whenever a squared b is equal to 1, whenever a squared b is equal to 1, for positive values of a and b, which of the following equations gives a in terms of b? So they want us to solve for a. This you can do under 30 seconds. You can. Divide b by both sides. Divide b by both sides. Alright? So a squared is 1 over b. Then take the square root of both sides. Take the square root of both sides. Square root of a squared is square root of 1 over b. So a is square root of 1 over b. Which is, okay, they want us to simplify further. Because you don't see this answer. You don't see this answer. So this is the same thing as square root of 1 over square root of b. So this means that a is equal to square root of 1 is 1 over square root of b. And that is option K. A is 1 over radical b, 1 over square root of b. Option K. Question 27 is ACT. Question 27 is ACT. And it's a word problem. But guess what? It's a word problem that is not just to confuse you. Don't be scared. The main thing is literal equation. So read it, understand it, that is literal equation, and continue. The value of a used car can be modeled by the formula V equal to V naught, V subscript 0 times 1 minus R exponent T raised to exponent T. So V naught is the initial. Where V naught, V0, V subscript 0, I call it V naught. V0, okay, V subscript 0 is the car's purchase price in dollars. R is the car's constant annual rate of decrease in value. R is the car's constant annual rate of decrease in value. expressed as a decimal. And V is the car's dollar value at the end of T years. See the variables, they are defining the variables. Which of the following equations shows the formula solved for R? For R. For R. For R. Alright, so let's do this. Please. You will need to know logarithms to solve this. Alright? You will need to know logarithms to solve it. You will also need we can also solve it without logarithms, but we want to make sure that we get the answer on the option, in the option. We want to make sure. So let's solve this. I think we'll do it two ways. Let's do it two ways, and we'll check which one has the answer in the option. So let's swap. Let us swap this. So V0 times 1 minus R exponent T is equal to V. Divide both sides by V0. Remember, we want to isolate R. We want to isolate R. So divide both sides by V0. So V0, 1 minus R exponent T over V0. Please, let me repeat. I am showing all my work. These exams are timed exams. So you should not spend all the time as I'm spending. I'm just showing all my work to make you to understand. Alright? But when you're solving it, note the time. Okay? So, now for CSEC, for CSEC, you have to show all your work. For CSEC. But for all this multiple choice, the main thing is to get the answer right at the minimum amount of time without exceeding the time limit. Alright, divide both sides by V0. So this divided by V0 equal to V divided by V0. So we now have 1 minus R exponent T is V over V0. So right here we can solve this two ways. We can solve this in two ways from here. Let's do it. So from here, 1 minus R exponent T is V over V0. We can take the logarithm of both sides. So we have log 1 minus R exponent T is log this first method by logarithms. Take the logarithm of both sides. Alright, so log 1 minus R exponent T equal to log, you have to put parentheses, okay, V over V0. So from the law of logarithms, please review my, if you go exponents-logarithms.hotspot.com. I taught logarithms very well. Okay, go to that website. Okay, you look at the law of logarithms there. So from law of logarithms, this will be T log 1 minus R. Alright, we're not going to do this by logarithm. I'm sorry. We will not do this by logarithm, no. Because we want to isolate R, not T. If you want to isolate T, then we can do it by logarithms. If you want to isolate T, we can do it by logarithms. But we are solving this for R. So we will not do it by logarithms. We will not. If we are solving for T, then we can do it by logarithms. Yeah. So please, I'm sorry, it's only one way we can do this, and that's not logarithms. We will now have to take the 1 over teeth root of both sides. I know you guys will say, what is it talking about? Okay, multiply both exponents by 1 over t. Because we want to free up this. We want to free it up. Okay? Multiply both exponents by 1 over t. So this means, now, this is what this means. V over V naught exponent 1. That is what it means. Multiply both exponents by 1 over t. So 1 minus r exponent t times 1 over t is equal to V over V naught 1 times 1 over t. So t crosses out t, that's it. So 1 minus r is V over V naught exponent 1 over t. You see what I'm doing? Alright. Now, if you want, you can add r to both sides. Alright? You can add r to both sides, but I just say rearrange. Okay? Rearrange. I'll be using rearrange from now on, please. Just rearrange. Rearrange means move this guy here, move this guy here. It is not swap. Swap means let the left-hand side be the right-hand side. Let the right-hand side be the left-hand side. But rearrange, you can say add arrow to both sides. I mean, this is the way American teachers will do it here. Hey, Mr. C, are you not an American teacher? Hi! Plus R. One will be V over V naught raised to 1 over t plus r. Then they will do minus V over V naught raised to power 1 over t minus V over V naught raised to power 1 over t. 1 minus V over V naught raised to power 1 over t equal to r. That is the way American teachers will do it. Then they will cross out like this. I mean, please, no disrespect. I am also an American teacher. You're working with time, okay? Just go and read my notes. Moving from here to here. It saves time. This is the way I read my notes about rearranging. Read my notes about rearranging. When you have this, 1 minus r equal to V over V naught exponent 1 over t. Rearranging, put this here, bring this here, period. So we have 1 minus V over V naught exponent 1 over t equal to r. That is it. When you move minus r to here, it's plus r. Now this one is plus. You bring it here, it's minus. Read my notes and view my videos on linear equations. Excuse me, on solving linear equations. View the whole videos. You will understand what I did here. So r is 1 minus, you now swap. R is 1 minus V over V naught exponent 1 over t. Let us see if it is in the answer. All right. Do you know what is the answer? Do you know what is in the answer? Now 1 over t means teeth root. Just like 1 over 2 is the square root. 1 over 3 is the cube root. 1 over 4 is the fourth root. So this is the fifth root. Fourth, just like fourth root. The th is silent. Fourth, fifth, sixth, seventh root. 1 over 7. Okay. If you go to my exponents and logarithms, exponents hyphen logarithms, math.appspot.com. Fractional exponents gives you radicals. So this is r equal to 1 minus fifth root of v over v naught. That is what is in the answer. Option A. Option A. Option A. Alright? But if you prefer this, that's okay. But you're working with time, ACT. So learn about rearranging. If you move from left to right or from right to left, that is what we call rearranging. Read my notes about it, watch my videos about it to save time to solve. ACT questions is 60 questions that should be solved in 60 minutes. So approximately you should solve one question in 1 minute. However, with ACT questions, some questions you can solve under 1 minute. Some questions will take you more than 1 minute. So the goal is to make sure you know how to maximize your time. Maximize your time. So the extra time you save from solving those questions that took you less than a minute to solve, you use that time you saved to solve the questions that will take you more than a minute to solve. That is the goal of the ACT. It's not just getting the questions right, but getting it right on time. Maximizing your time. Some questions on ACT will take you about 20 seconds to solve, and some will take you more than a minute. So you save that time. If you solve a question in 20 seconds, that 40 seconds you saved, use it to now solve questions that will take more than a minute. Alright? So you have to know how to do shortcuts, effective shortcuts to save time. Okay, rather than doing this way, if you know rearranging, okay, I'm not gonna come here, and start teaching rearranging. Just read it and view the videos on linear equations, how I explain rearranging. If you're moving from left to right or moving from right to left, right? Next question is question 28. Question 28 is JAMB. The weight W kilogram of a metal bar varies jointly as its length L meters. Now this is I know some people will say it's joint variation. I understand, but it is also literal equations. So it doesn't matter, let's solve it. Okay, right? The weight W kilogram of a metal bar varies jointly as its length L meters. So W varies jointly as the length meters, length L meters, and the square of its diameter D meters. Square of the diameters D squared. So this is the variation of proportion. Variation of proportion. So we have to form an equation. Okay, so W will now be KLB squared. This is the equation, where K is a constant. K is a constant of proportionality. Constant of the proportionality. So you have a proportion. Let's the actual term. Let's use proportion. This one is the proportion, and then you convert it to an equation by putting in constant K, or any constant you like, provided you put a constant, but K is common. Now you only change K if K is in the variable in the question. Otherwise, it's better to go with K. But you can use any variable you want to. If W is 140, W is 140, when D is 4 2/3, D is 4 whole number 2/3, 4 2/3, and L is 54. L is 54. Find D in terms of W and L. So for D, solve for D. Yeah, they gave us this first, so we can find the constant of proportionality. Alright? Yeah. So let's find this first. So W is equal to KLD squared. Swap. KLD squared is equal to W. Divide both sides by LD squared. So KLD squared divided by LD squared is W over LD squared. Alright? Yeah, I got this one. I got that one. Thank God I got that one. Trying to write this. Alright. So you cross this out. K is equal to W over LD squared. Right? And we see that D has a fraction. D has a fraction. So let's just make things easier for us. LD squared, let's find LD squared first. D is 4 whole number 2/3, which is 3 times 4, 12, plus 2, 14, 14/3. So let's find LD squared. Please, it's good to break it down. So, especially if you have fractions. If you have fractions, it is good to break it down. Do it in bits and pieces. Alright? Break it down. So this will be L. L is 54. L is 54 times D squared. So 14/3 times 14/3. JAMB, we don't allow calculators. We don't. 3 times 3 is 9. 9 into 54 is 6. Alright? 3 times 3, 9. 9 into 54 is 6. So we have 6 times 14 times 14. Alright. W divided by LD squared will be W divided by LD squared, which will give us W is 140. 140 divided by 6 times 14 times 14. So this is 140 divided by, let me just write it, divided by 6 times 14 times 14. So 14 divide 14 is 1. 14 divide 140 is 10. 10. Right? 2 divide 6 is 3. 2 divide 10 is 5. So this will be 5 over, 3 times 14 is 42. 5 over 42. So K is equal to 5 over 42. That's K. K is 5 over 42. Alright? the next thing we need to do now is, oh, I shouldn't have erased all those, I should not, but that's okay. We have that W is equal to KLD squared, and we need to find this for D. We need to find this for D. All right, so swap KLD squared is equal to W. Right? Divide both sides by KL. So KL B squared divided by KL is equal to W over KL. Bam, bam. So we have that B squared is equal to W over KL. But our K is 5 over 42. Our K is 5 over 42. So when you do KL is 5 over 42 times L, which is 5L over 42. That is KL. W over KL is W divided by KL, which is W divided by 5L over 42, which is W times 42 over 5L. You see how I'm breaking this down. W times 42 over 5L. So this means this will now be 42W over 5L. So we now have that our D squared is 42W over 5L. See that? Then you take the square root of both sides. Take the square root of both sides. So our D is now square root of 42W over 5L. That becomes the answer. That is option A. Option A. All right. Question 29. Question 29. Question 29. Question 29 is CSEC. CSEC. It says here, given the formula S is equal to 1/2 times U plus V times T. Express U in terms of V, S, and T. Express U in terms of V, S, and T. So this is for U. Solve this for U. All right. Let's swap. So we have half times U plus V times T equal to S. Multiply both sides by 2. Multiply both sides by 2. 2 times half. We can just say half T U plus V. We can have it like this. Equal to 2 times S. 2S. So bam, bam, this goes. So we now have 1 times T is T. T times U plus V is equal to 2S. Is equal to 2S. Divide both sides by t. Divide both sides by t. So you have u plus v is equal to 2s over t. Right? U plus v equal to 2s over t. Subtract v from both sides. Subtract v from both sides. So u plus v minus v is 2s over t minus v. V minus v goes. So u is 2s over t minus v. This is the answer. However, some might want you to simplify further. They might want you to get this as one fraction. So in that case, we have that LCD, because this means 2s over t minus v over 1. That is what it means. So, I mean, this is correct. I will mark this correct with the full points. Yeah, but some might want you to simplify further. And this is CSEC, so you should mark it right. But it's also good to simplify further. Okay. LCD, so we have u equal to, LCD is t. T into t is 1. 1 times 2s is 2s. Minus 1 into t is t. T times v is vt. So this is correct. This is also correct. But this is just as one fraction. This is just as one fraction. Yeah. Now, some people might say, hey, Mr. C, I didn't understand what you did. This is what I did here. This is 2s over t minus vt over t. Because they have to have a common denominator. They have to have a common denominator for you to subtract. Yeah. And the common denominator is t. For you to subtract. Then you make this as the equivalent fraction. This v over 1 and vt over t is equivalent. You have to express the equivalent fraction just for them to have a common denominator. Alright? Look at my videos on fractions. Question 30. Question 30 is also CSEC. CSEC. It says, make t the subject of the formula. Make t the subject of the formula. Make t the subject of the formula. P over 2 equal to square root of t plus r over g. T plus r over g. So solve for t. Make t the subject of the formula. Let us swap. Swap. So we have square root of t plus r over g equal to p over 2. Square both sides. Square both sides. So square root of t plus r over g all squared is p over 2 all squared. Square both sides. The square of the square root of a term is the term. So this implies that t plus r over g is equal to p squared over 4. Because that is p squared over 2 squared. Okay, this is p squared over 2 squared, which is p squared over 4. Multiply both sides by g. Multiply both sides by g. G times t plus r over g equal to g p squared over 4. G times p squared over 4. If you want to write it this way, that's fine. we will still write it the other way. G times P squared over 4. G crosses out G. So we have that T plus R is equal to GP squared over 4. Subtract R from both sides. Subtract R from both sides. Subtract R from both sides. So T plus R minus R is GP squared over 4 minus R. So this means that T is GP squared over 4 minus 4R over 4. If we put it to have the same common denominator. I mean, if you want to leave it this way, this is still okay. This is still okay. However, they might want you to simplify further as a single fraction. So in that case, you have a common denominator. You have to put a common denominator, which is 4. 4 into 4 is 1. 1 times GP squared is GP squared. And this is T equal to. Then minus, this means R over 1. That is what it means, R over 1. 1 into 4 is 4. 4 times R is 4R. So T is GP squared minus 4R over 4. It is still correct. It is still correct. Okay, it is still correct. Yeah. All right, that is question 30. Question 31. 31. Question 31. Question 31 is WASSCE. Question 31 is WASSCE. Given that, this one you need the knowledge of logarithms. Given that log y base 10 is equal to 1 plus 3 log x base 10. Express y in terms of x. So solve this for x. Please, if you go to the website www.exponents-logarithms.appspot.com, I taught exponents and logarithms very well. Okay, so please, you need that knowledge, the laws of exponents and laws of logarithms, because we need that for this. So we can cancel logarithms. We can make one, because this is in log base 10. This is also in log base 10. And from the options, if you look at the options, there's no logarithms there. So that means they cancelled logarithms. So we need to express 1 as a logarithm in base 10. So this is log y base 10 is 1 is log 1 exponent 10 base 10. Log 10 exponent 1 base 10. That is the way we express it. If you want to express 1 in log base 5, it is log to base 5, 5 exponent 1. If you want to express 3 in log base 5, it is log to base 5 of 5 exponent 3. Because that is 3 log 5 base 5, which is 3. So if you want to express 7 in log base 5, it is log in base 5 of 5 exponent 7. Okay, because that is 7 log 5 base 5, which is 1. Log 5 base 5 is 1, so 7 times 1 is 7. So please look at that video. So you want to express 1 in log to base 10, it is log to base 10 of 10 exponent 1. Okay, because this is 1 log 10 base 10, and log 10 base 10 is 1. Log 7 base 7 is 1. So this is like 1 times 1. Alright? So this is log 10 exponent 1 in base 10 plus. Now we can check this now from laws of log. This is log x cubed base 10. Log x cubed base 10. So this is log y base 10 equal to log 10 exponent 1 is 10. Log 10 base 10 plus log x cubed base 10. So this will be log y base 10 equal to law of logarithms, law 1. Alright, this is log to base 10. This is 10 times x cubed. So this means that log y base 10 is equal to log 10x cubed base 10. Now you cancel logarithms. Cancel logarithms. Alright, cancel logarithms. We have log y base 10 equal to log 10x cubed base 10. So cancel logarithms. Bam, bam. So y is equal to 10x cubed. But they want us to solve this for x. Swap. 10x cubed is equal to y. Divide both sides by 10. 10x cubed over 10 equal to y over 10. I hope they want us to solve it for, express y in terms of x. So this is for y, please. Yeah, for y. So for y, this is the answer here for y. But if you want to solve it for x, let's just finish it for y and for x. Yeah. Because I was looking at the options and I didn't see any cube roots. So the answer is for y. Y is 10x cubed, and that is option A. Option A. But let's finish it. Let's finish it for x as well. So divide both sides by 10. Bam, bam. So x cubed is y over 10. Take the cube root. Take the cube root of both sides. Cube root of x cubed is x. Then cube root of y over 10. So this means that x is cube root of y over 10. That is for x. Alright. Question 32. Let's see how many we can solve tonight. Even if we do not solve all of them, but let's see how many. Let's solve some more. Alright? Let us solve some more. Question 32. We have, that is JAMB. If P is equal to square root of RS cubed over T, square root of RS cubed over T. Express R in terms of P, S, and T. So let's see how many we could, let's do some, let's see how many more we can do tonight, and then we shall have part 4 where we can solve more. How about that? Okay, by the grace of God, we have another one by part 4, so we can solve more. But let's do some more. Right. Okay, so solve this for R. Express R in terms of P, S, and T. Means we should solve this for R. Let us swap. We have square root of RS cubed over T equal to P. Cube both sides. Sorry, not cube both sides. Square both sides. Square both sides. So square root of RS cubed over T all squared is equal to P squared. So this is RS cubed over T equal to P squared. Multiply both sides by T. Multiply both sides by T. This will be T times RS cubed over T equal to TP squared. T times P squared. We now have RS cubed equal to TP squared. Divide both sides by S cubed. Divide both sides by S cubed. RS cubed divided by S cubed equal to TP squared divided by S cubed. So R will be TP squared divided by S cubed. And that is the option TP squared. Okay, we have here PT squared. So they have it as P squared T is what they have it over S cubed. They have it as P squared T over S cubed. Option A. That is option A. Alright. 33 is WASSCE. 33 is the next question. And it is WASSCE. 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 If P, Q, R, S are all positive and P is equal to square root of Q squared minus R squared over S squared minus R squared over S squared. Make S the subject of the relation. Make S the subject of the relation. So this is 4S. 4S. Let's not swap now. Let's not swap right now. Okay? And some people might say, why? We've always been swapping. Well, if we swap, we will need to swap again. That's why. Because S here is in the denominator. But you can do it. You can swap if you don't. If you want to. Yeah. But I will say, let's release this radicand. We call it radicand. The term inside a radical is called a radicand. Let's release it. It's in bondage. Release. Release. So square both sides. Square both sides. So we have P squared. This is lowercase p, right? Yeah. So P squared is square root of Q squared minus R squared over S squared all squared. So this means that P squared is Q squared minus R squared over S squared. Now let's rearrange. Let's Let's rearrange. I don't like this minus, so let's rearrange. Put this minus back here, bring the p squared back here. As you're doing this, be checking at the option to make sure, because whatever we solve, we want to see it in the option. We want our answer to be in the option. So, move this here, bring this here. So we now have that r squared over s squared is equal to q squared minus p squared. Alright? So, I will say multiply both sides by s squared. And it's okay if we have swapped. We would, yeah, that's okay. We probably wouldn't, yeah. But it's okay. Multiply both sides by s squared. Yeah. Some people might also do this, which is better. If you want to multiply both sides by s squared, that's fine. But some people will do this like this. R squared over s squared is q squared minus p squared over 1. So you can do cross product. And you don't need to multiply both sides by s squared and then you swap again. Yeah. So this is q squared minus p squared over 1. Then you can use cross product. This times this equal to this times this. See that? So s squared times q squared minus p squared equal to r squared times 1. Right? So s squared times q squared minus p squared equal to r squared. R squared times 1 is r squared. Divide both sides by q squared minus p squared. Divide both sides by q squared minus p squared. So s squared q squared minus p squared divided by q squared minus p squared equal to r squared over q squared minus p squared. So we have that s squared is r squared over q squared minus p squared. Right? Take the square root of both sides. Let me touch my laptop. Take the square root of both sides so you can find s. So this will now be square root of s squared is square root of r squared over q squared minus p squared. So s is square root of r squared over q squared minus p squared. We can simplify this further, but let us look at whether to see the option. Alright, the option we need to simplify further. So s will be square root of r squared over square root of q squared minus p squared. So s will be r over square root of q squared minus p squared. And this is the answer here. That is the answer. Square root of q squared. Yeah. That is option C. Option C. Question 34 is also WASSCE. Make x the subject of the relation x over q minus 2 is equal to x over p. X over q minus 2 is equal to x over p. Yeah, so let's rearrange, let's get the x's together. Let's get the x's together. If you want also, you can multiply everybody if you don't like the fractions. That's another way to do it. If you don't like the fractions, you know, you have fractions there, and if you don't like the fractions, multiply everybody by the LCD. Okay, we can do that. Let's do that. LCD is PQ. So multiply everybody by PQ. This is one way. You can solve this another way. We can. Okay, I'll show you. All right. But let's solve this first method. If you don't like fractions like that, multiply everybody by the LCD. So we have PQ times x minus q minus PQ times 2 equal to PQ times x over p. Alright? Wow! I got that. I got it. So, Q cancels Q, bam bam, and P cancels P here. So we have px minus 2pq equal to qx. Now this is the same thing as this, just without a fraction. Same thing, if you don't like fractions. Alright, get the like terms in x, rearrange, bring this over here, push this over here. So we have px minus qx equal to 2pq. Factor the left hand side by the GCF. Okay, factor the left hand side by the GCF. The GCF is x. So we have x times p minus q equal to 2pq. Divide both sides by p minus q. Divide both sides by p minus q. Divide both sides by p minus q. So we have x, p minus q, divided by p minus q is equal to 2pq divided by p minus q. Right? So x is 2pq divided by p minus q. And that is option D. Option D. Now, if you also want second method we can do. Second method we can do is we can here x over q minus 2 equal to x over p. We can rearrange, get the like terms in x, and push 2 out. So we have x over q minus x over p equal to 2. Right? So we can solve it as a fraction. Here in this first method, we didn't solve it as a fraction. We did not solve it as a fraction. But the second method, we can solve it as a fraction. So LCD is PQ. Q divide PQ is P. P times X is PX. Minus P divide PQ is Q. Q times X is QX. Equal to 2. I can call it 2 over 1. So we can use cross product. Cross multiply. Now we can use cross multiply. Or if you don't want to use cross multiply, You can multiply both sides. So we have PQ. This is a PX minus, because we've used cross multiply. So let's use another one now. We've used it in the previous question. So you can do several methods, provided it is accurate. P into PQ, Q times XQX equal to 2. You can multiply both sides by PQ. You can. Multiply both sides by PQ. PQ times PX minus QX over PQ equal to PQ times 2. Or you can just do cross product. Cross multiply, you can. Bam, bam. So we have PX minus QX equal to 2 PQ. Alright? And you finish it. And you finish it. Okay? We were working with time, so we just finished that. Alright. Next question is question 35. Question 35 is WASSCE. Given that R is equal to xy over 2 and x is v over w. X is v over w. Express R in terms of y, v, and w. So for R, we want to express it in terms of y, v, and w. So we want to see R by itself, but we want to see something in y, we want to see something in v, and we want to see something in w. That is what it means. So we want to see arrow equal to something that has y, v, and w. All right, y, v, w. So let's look at this from here. We can call this equation 1 and equation 2. We can do that. Okay? From equation, you can call this equation 1, you call this equation 2. From equation 2, x is v over w. So xy will be v over w times y. And that will give us vy over w. Right? Vy over w. Now xy over 2 means vy over w means xy divided by 2. That is what it means. Please, when you are dealing with fractions dividing, do it step by step. Because students normally make mistake here. They put xy, vy over w all over 2, and they might make a mistake. So we see that xy gives us a fraction, so I'll just say xy divided by 2 is xy divided by 2. This is now vy over w divided by 2. Divided by 2. Which is now vy over w times 1 over 2. Because this means divided by 2 over 1. So when you're dividing fractions, you flip the fraction on the right hand side. You flip the fraction on the right hand side. So this will now give us vy times 1 is vy over w times 2 is 2w. So that is it. So this means that our arrow is vy over 2w. That is it. Vy over 2w. And that is Vy over 2w. That is option D. Option D. Option D. D as in David. David. All right. Question 36. Question 36. It's JAMB. Question 36 is JAMB. Make, excuse me. Make Q the subject of the formula if P is equal to M over 5 times X plus Q close the parentheses, then plus 1. You're solving this for Q. For Q. Alright. Let us swap. Let's swap. So this is M over 5 times X plus Q plus 1 equal to P. Subtract 1 from both sides. Subtract 1 from both sides. So we have, now this means M times X plus Q over 5. That is what it means. That is what it means. Alright? Because this is M times this divided by 5. Plus 1 minus 1 equal to P minus 1. Subtract 1 from both sides. So 1 minus 1 is gone. Alright? Ooh, I missed that. It touched it though, it touched it. But I missed it. That's okay. So we now have M times X plus Q over 5 equal to P minus 1. Right? Multiply both sides by 5. Multiplica. Multiplica. Multiplica by 5. Multiplica by 5. Multiply both sides by 5. Multiply both sides by 5. So we have 5 times M times X plus Q. Let's use a bracket here because we already have a parenthesis. All over 5 is equal to 5 times P minus 1. Right? So 5 divided 5, that's it. We now have M times X plus Q equal to 5 times P minus 1. Divide both sides by M. Divide both sides by M. So we have M times X plus Q divided by M is equal to 5 times P minus 1 divided by M. Right? So we now have M divide M. Bam, bam. That is gone. So X plus Q is equal to 5 times P minus 1 over M. And now subtract X from both sides. Subtract X from both sides. So X plus Q minus X is 5P minus 1 over M minus X. X minus X is gone. So we now have that Q is equal to 5 times P minus 1 over M minus X. Let us see if this answer is there. Alright, it is not there. So let us simplify further. They want us to simplify further. So this means x over 1. So LCD is m. M into n is 1. 1 times this is 5p minus 1 minus, put equal to this. 1 into m is m. M times x is mx. Alright? So this answer is not there. They want us to simplify further. They want us to distribute. So Q is equal to 5p minus 5 minus mx all over m. Alright? And they want us to simplify further. They want us to simplify further. 5p 5 p minus 1. I want to make sure that that is the actual question. 5p minus mx minus 5. Yeah. So I have to, the option will be 5p minus mx minus 5 over m. That is it. And that is option A. 5p minus mx minus 5 over m. Option A. Alright. Let's do question 37. Question 37 is CSEC. CSEC. Question 37 is CSEC. Let's do some more and then we will call it a night. Yeah. Question 37 is CSEC. It says, make arrow the subject of each of the following formula. Make arrow the subject of each of the following formula. So it has two sub-questions. Two sub-questions. Arrow minus h equal to arrow h. So let's do this one and then we'll do another sub-question. So let's rearrange. Bring this over here, take this over here. Arrow minus arrow h is equal to h. Factor the left-hand side by GCF. GCF is arrow. So we have arrow 1 minus h equal to h. Then divide both sides by 1 minus h. Divide both sides by 1 minus h. So r is equal to h over 1 minus h. That is the first sub-question. The first sub-question. Then the second sub-question is v equal to pi squared pi arrow squared h. Pi arrow squared h. Alright, so swap. Pi arrow squared h equal to v. Divide both sides by pi h. So pi arrow squared h over pi h equal to v over pi h. So we have that arrow squared is v over pi h. Take the square root of both sides. Take the square root of both sides. Square root of arrow squared is square root of v over pi h. So this implies that r is equal to square root of V over pi h. That's it. That is it. All right? Okay, the next one is question 38. It's also CSEC. CSEC. Make x the subject of the formula. We have y equal to x over 5 plus 3p. Y equal to x over 5 plus 3p. So swap. Let's swap. X over 5 plus 3p equal to y. Subtract 3p from both sides. Subtract 3p from both sides. So x over 5 plus 3p minus 3p equal to y minus 3p. So 3p minus 3p is gone. Now we now have x over 5 equal to y minus 3p. Multiply both sides by 5. Multiply both sides by 5. Because this is solved for x. This is solved for x. This is solved for x. And these ones are solved for h, solved for h. Multiply both sides by 5. So we have 5 times x over 5 is 5 times y minus 3p. So our x is 5 times y minus 3p. That's it. Right? Is it, please, pause, before any question, pause it, solve it on your own. I've been walking you through all these steps so that you can look at the way we isolate it. Alright, so try it on your own, then you start playing the video again, and you compare your answers with mine. 39, let's do about 2 more, 39 and 40. Then we'll call it a night. And we'll watch out for part 4. We look out for part 4. Alright, 39 is JAMB. 39 is JAMB. Make arrow the subject of the formula if t equal to k arrow squared plus m over 3 plus m over 3. We are solving this for arrow. Make arrow the subject of the formula. Alright. Multiply both sides by 3. Okay. Multiply both sides by 3. So 3t is 3 times k arrow squared plus m over 3. Bam, bam. So 3t is equal to k arrow squared plus m. Swap. Swap. K arrow squared plus m is equal to 3t. Subtract m from both sides. Subtract m from both sides. So we have k arrow squared plus m minus m is equal to 3t minus m. This is gone. M minus m is gone. So we have k arrow squared equal to 3t minus m. Divide both sides by k. Divide both sides by k. Divide both sides by k. So we have k r squared divided by k is equal to 3t minus m divided by k. So we have r squared is 3t minus m divided by k. Take the square root of both sides. Take the square root of both sides. So you can now isolate r. So square root of r squared is square root of 3t minus m over k. So this means that r is square root of 3t minus m all over k. Let us check the option. Square root of 3t minus m over k. Option D. Yes, option D. Okay, question 40. Question 40 is WASSCE. WASSCE. Given that p exponent 1 over 3 is equal to cube root of q, cube root of q over r. Make q the subject of the equation. So solve this for q. For q. Make q the subject of the equation. Multiply r by both sides. How about it? Multiply r by both sides. Multiply r by both sides. So r p raised to exponent 1 over 3. This is cube root of p. Alright, but I don't see cube root of p here. So let's just keep going. Yeah. rp exponent 1 over 3 equal to cube r times cube root of q over r. So we have that rp exponent 1 over 3 is cube root of q. Cube root of q. Swap. Swap, we have that cube root of q is rp exponent 1 over 3. Alright? Cube both sides. Cube both sides. Cube both sides. So we have that cube root of q all cube is equal to rp exponent 1 over 3 all cube. Cube root of the cube of the cube root of q is just q. So q is r cubed times p 1 over 3 times 3. This is exponents. www.exponents-logarithms.appspot.com, or go to my websites, my samuelchukwuemeka.com or chukwuemekasamuel.com. Click on algebra, click on exponents and logarithms. Right? So q is now r cubed times p, because 3 times 1 over 3 is 1. So q is r cubed p, or p r cubed. That's what they have there. Q is p r cubed. All right. So, I missed one. Okay. Folks, we started from question 19 and we stopped at question 40. Let us call it a night. Alright? So, when we have time again, by the grace of God, we'll continue with part 4. We'll continue from question 41. Alright? So, thank you so much for listening. If you have any questions, please feel free to ask.
And you have a good night.